Manasvita, welcome. Thank you for being here with us today. Really been looking forward to today's episode. I guess by way of introduction, Manasvita, you are the Associate Director for Data Science and Research Facilitation at the largest research team of Harvard University. And I know from our previous conversations, doing some really interesting work there. A lot of the work you're doing seemingly a blend of data science, machine learning, high performance computing. So really super excited to chat with you today and hear a little bit more about your role and your approach. So before we do, it would be lovely just to learn a little bit more about you, your background. So if you kindly, give us a little bit of an overview of your career to date, how you've ended up in the position that you have, that would be fantastic.
Yeah, thank you, Guy, for that lovely introduction. Happy to be here and excited to talk about what I've learned so far and what I'm doing in my role currently. But to just talk a bit about where I come from and how I actually got into this
Yeah.
area altogether. So originally, I'm from Delhi, India. So my entire schooling has been in Delhi. Went to Delhi University for my bachelor's, then went to IIT Delhi for my master's, and then came to Ohio University to pursue a PhD in astronomy. So growing up, I somehow just always loved physics. I wanted to know more about space. And I remember it was, I think, 97 when Cassini probe mission was launched in October of that year. And I ended up dreaming of, so Cassini was supposed to, it was a Saturn mission, but it was going via Jupiter. So somehow in the news, I remember hearing a lot about Jupiter. I don't know why and how, but one of those nights I ended up dreaming of a supermarket in Jupiter, which is completely not possible because it's a gas giant. But anyhow, so I knew that okay, this is something that I would like to pursue, and I think for that, the other skill that I needed to add was computer science. But in high school, I think when I started learning about computer science, so 3 months into the academic year, the teacher told me that, Manasvita, there is still time to transfer to biology because you're not doing well in computer science.
Oh,
So,
right.
so
Okay.
that day, I was like, man, I need to do something about this. So I went back home and just locked myself in my room and really taught myself the whole logic or concept of looping, because I think that was where I was missing the whole point, and I was just not being able to score because I just did not understand how loops worked. So
Okay.
I literally, like, just taught myself step by step every single iteration, how it goes through, in a loop. And since then,
Never look
it
back.
it was a complete transformation. So yeah, had it not been for that day, I don't think I would have been here. So that day, I think, really taught me the importance of self-learning,
Yeah,
self-teaching. So yeah.
absolutely. Absolutely.
So moving on, so coming to Ohio University, I was a grad student in astronomy. So basically, decided to do my thesis in high energy astrophysics. And it was mostly a theoretical thesis, but with some observational elements. So I would go to observe the sources that I was working on from time to time. But on the numerical side, I had built a numerical model to understand the emission from the central portion of certain extragalactic sources. So extragalactic sources are the sources that are not in our galaxies. These are extragalactic.
Yeah.
And these sources have supermassive black holes residing in them in their central portion. And the emission that is generated from this central portion is in the form of jets. And the reason why I said certain extragalactic sources, because so many extragalactic sources have supermassive black holes, but the reason why they're certain is because these jets that are emanating from the central portion, they happen to be actually aligned along our line of sight. So we are looking right into the jet. And in a way, this is a good thing because the whole emission is jet dominated. So we can really study the physics of what is going inside the jet. And the reason why this is special is because this emission actually has very high energy photons that can be observed from these jets. And the emission is actually a result of particle acceleration that is happening inside a jet. But what we are trying to understand, or what we don't understand, is the mechanism that is responsible for accelerating these particles to such high energies that they're being able to produce photons in TeV range. So we are talking about tera electron volts. So that is something which we have not been able to achieve here on any man-made accelerator on Earth. So understanding the mechanisms that go behind accelerating the particles could have huge impact on high energy physics, on particle accelerators on Earth. And that is why this was, of so much interest to me. So I actually built the model to understand the emission that is coming from these jets and actually do whole reverse engineering on it to figure out what the physics is behind. So because the emission is the final product that we are seeing. So you
Yeah.
have to do reverse engineering to figure out what are the input parameters that are producing this output.
Yeah. Yeah.
And so yeah, so I mean, I can continue talking about the numerical model that I built, but so it basically just accounted for that one. So there are multiple types of particle acceleration mechanisms, but I essentially just used one of those. And the multiple processes, that are responsible for producing photons from those accelerated particles was exactly the main focus of this model. And as I said, I performed reverse engineering. So I would start with the observed data, clean it up. If it was already not cleaned, then analyze it using this numerical model. So I call it MUSORF because it stands for multi-zone radiation feedback. So I would use this MUSORF to perform multiple simulations and fitting the results of those simulations against the data. So in a way, I would say that from my graduate years onward, my entire research has been essentially very data science focused because it was all about data collection, data cleaning, initial data analysis,
Mm.
exploring the relevant parameter space, and then iterating over it to find the successful model. So it was already a part of my workflow as a
Yeah.
grad student.
It's amazing
And
how many people were doing data science before they realized it was data
I,
science,
I
right?
know. So because when the buzzword came, I was like, I think that's what most science grad students already do. They
Yeah.
do
Yeah.
realize that, right?
Yeah.
So yeah, and then so the only difference was, unlike in data science or machine learning, the model deployment is, very different. It was basically typically in the form of presenting your work in a conference or getting your work published in a paper. So that final piece was very different, which is something that I learned about when I switched. But yeah, but when I was in astronomy, the I would say 80% of the workflow was very similar to what it is in data
Mm.
science.
Yeah.
And then after that, I came to Boston University to pursue my research. I taught multiple astronomy courses at grad and undergrad level. And then there was data science boom. So I kind of started thinking about how I can actually apply my skills into this area and vice versa. Like, some of the models, the technologies that data science already has encapsulated, how can that be applied to astronomy? So I kind of started thinking about that. And as a result of it, I actually worked at a startup as a data scientist for about three-fourths of a year. And they were dealing with a really interesting problem, which was related to hearables. And my job was to actually analyze the signal both scientifically, just using some numerical modeling and also using some ML methods. So it was, a great learning experience. But then, I was interested in really applying my research and mentoring and teaching skills in an area that's challenging, but is also closer to academia. So I kind of wanted to have that experience. And I think I can safely say that I found that good balance between academia and industry through research computing, which is what I am in now. So my first job in research computing area was at Northeastern University, and I'm really grateful for that job. So I was an associate data scientist there, and in the same research computing area. And then from there, I, transitioned to Harvard University recently. And it's been wonderful so far.
Wow, fantastic. What a genuinely really interesting story. And I think we've spoken about this before, but it is one of the reasons I love this field, data science and machine learning and I guess AI where we are today, because people, it attracts very bright, very gifted individuals, very numerical in many ways. And they kind of come into this field. And I think, do you feel that your astronomy background, how has that impacted you on the way you see the world of data science? Clearly, it's a hugely analytical and numerical field in itself, but do you feel that particular field has been able to positively impact you as a data scientist and sort of shape your view on how you see data science and machine learning initiatives?
Oh yes, absolutely. I think my research background has helped me tremendously in understanding what the data is when you deal with a problem. And I think most importantly, having this background kind of teaches you to be not afraid
Yeah.
from data, right? So a lot of time, I mean, at least in my experience, what I've seen is when new people come into data science, machine learning field, without having that kind of a background, you could be a little bit apprehensive about the data. You may not really know how to understand the data, how to process it, because if you don't understand the story behind the data, you may not be able to process it properly, and then the whole problem will propagate throughout. So having that research background, having followed a scientific method, helps me with having that workflow in data science as well.
Yes.
So I do tell all my colleagues that had it not been for the research background, I would not have felt this comfortable with being in data science.
Yes, yeah, I think that's a great way of looking at it. So you're now in this sounds like super exciting field and team within Harvard University. So tell us a little bit about your role there and the team that you're in.
Yeah, so at Harvard University, there are multiple research computing teams because there are multiple supercomputing clusters. They span all kinds of sizes. Some are mini, some are medium sized. But the team that I am with, we manage the largest supercomputing cluster of Howard University. It's called Cannon, and the team that I'm associated with, it is actually part of the Faculty of Arts and Science at division at Howard University. So we are the Faculty of Arts and Science Research Computing, or FASRC for short.
Mhm.
And what we what we actually do is that the Howard University, along with five other universities, has actually partnered with a data center in the New England area. And this data center is the LEED Platinum Green Data Center, to offload some of the power and cooling requirements that come with setting up and managing a compute cluster. So the data center, which is called the Massachusetts Green High Performance Computing Center, or MGHPCC for short,
Mhm.
is actually located in a place called Holyoke in this state of Massachusetts. But we also have two other small data centers that are located in Boston and Cambridge in Massachusetts. So, in a way, we actually connect all these three data centers together to give our users a unified environment, or a unified experience of um, computing on our cluster. So that's kind of the extent of what the team manages. And just to kind of put few numbers to that. So as I said, the Howard's largest supercomputing cluster, Canon, is managed by us, FastRC. Um, and that's our primary compute. But then the one in Boston and Cambridge, they essentially have other systems, that includes our storage, the login nodes, the VMs, and even some specialty computes. Those kind of systems are all located across Boston and Cambridge. So in that sense, the scale of the entire cluster that our team is managing is actually spread over three data centers.
Wow.
And yeah, and in terms of the staffing strength, the FastRC staff is nearly comprised of 25 members to support and manage the cluster hardware, software, network. And when I say support, support also includes user and research facilitation. And this is where the data science and research facilitation group, my group, comes into play. So the whole user and research facilitation actually forms a very important part of any research computing team in a
Mm.
university, or in an organization. The reason being that if you don't have a way to communicate to the users on how to execute their workflow on the cluster, so it's a complete waste then. You can have as many resources you want, but if you're not investing in training your users on how to use those resources, it's a complete waste of your infrastructure then. So the research facilitation is a very big component of any research computing team in that way.
Yes, yeah, absolutely. I'd be really interested to hear in a moment a little bit more about your approach to how you do guide users, around that facilitation piece, because I can understand how important that is. But before we get on to that, really interesting to understand the setup of the FastRC logistically. So, can you talk us through some of the projects you're involved with there within FastRC, and yeah, give us a little bit of an overview of some of the work you're doing.
Yeah, sure. So, as part of the research facilitation group at FastRC, we are really branched, I would say, in three, four areas. So, as I already said, research facilitation is a big component, is a big part of it. So that already includes that, we have to think about documentation, we have to think about training our users, we have to think about doing workshops. But now, just having training, workshop, or documentation on regular stuff is not enough, because you need to have enough understanding of the latest technology in order to educate the user, which
Mm,
means you need to have time to do your own internal research to assess the technology, understand how to implement that technology on the cluster, and then based on those findings, prepare a documentation or a training module or a
mm,
workshop. So it's not just about knowing the standard procedures and protocols for putting a workflow. It's actually going above and beyond that.
mm,
So in that respect, we try to do a lot of internal projects which are about benchmarking, let's say, a certain software. It could even be, let's benchmark a storage system if we want to, uh, give it to our users. But then before that, we want to evaluate the storage system internally with our own tests. So of course, the storage team would do that, but they will do it mostly from the hardware point of view. We try to do it from the scientific software point of view. That if we just, put a scientific software, and then simulate something which is really bashing the system, exactly how well the system is able to handle that. So that is a kind of stress test we would like to do. So that's, let's say in the benchmarking area.
Mm.
Then we have projects in the optimization area where now you want to see how you can optimize a given Python code. And some of these could be a very generalized things because if you're, let's say, collaborating with some research groups that are exclusively using Python, it could be a different thing. But a lot of times, in order to guide general users, you want to have some general tips and tricks. And how do you come up with that? You want to do your own study of, if I have a given Python code, how I can optimize it. So
Mm.
that's, and then the other thing that I'm directly involved in is doing some data science, machine learning on the data that the cluster generates on a daily basis. So we in FastRC get close to 90,000 jobs submitted on the cluster on a daily basis. I think just yesterday I was checking in, I think it was in 5 minutes, we had close to 300 jobs submitted in 5 minutes. So that's the extent or the level of jobs or the level of data we get on a daily basis. So we can then query the database with all this data, clean it up, and process it so that we can kind of ask or get answers to some questions that are part of HPC domain, the high performance computing domain. So some of those questions are, hey, can we estimate the wait time that a user will face after they submit their job on the cluster? Is it going to be a few seconds or minutes or hours? So that is a long-standing question. People have done a good amount of work on it, but then a lot of times what also happens is, even if you have solved that problem, now you need to figure out how to deploy that model on a cluster that is shared across all users. So
Mm.
you have to, there's a different set of constraints that you're thinking about when you're thinking about model deployment on
Mm.
this kind of a cluster. Then the other problem is, or question is, can we, based on a user's history of what type of resources they have utilized while running their jobs on the cluster, can we recommend them that maybe this combination of resources is going to be optimal? So could we think about a recommendation engine in this case? So all those kind of questions are there that I am working on, I would say semi-actively, because our work overall is very interruption driven. So, a lot of times in a single day, we are thinking about 4 to 5 different things, which includes ticket resolution, documentation, thinking about training, so all that. And then in addition, doing your internal projects. But that's just like, a sense of what type of internal projects are relevant to our group within a research computing team.
Wow, fantastic. That's obviously a pretty incredible number, having 90,000 jobs requested. So how do you actually go about supporting that from a hardware point of view? What does that look like to even manage that?
Yeah, I know that's a good question. It's a massive scale, actually. So the FastRC team that manages Canon cluster is actually comprised of close to 2,000 plus nodes, which are these, the servers. And on that, we have almost about 95,000 CPU cores that are, that's the sum total of it, along with 900 plus GPUs that we offer to our users. And the way the whole thing is set up is our primary compute is, as I said, in this lead platinum data center, which is stationed in Holyoke in Massachusetts. So that's close to around about, I would say, 100 miles or so from the Boston area. And the other two data centers, as I said, are in Boston and Cambridge. Now, the compute nodes that are stationed in Holyoke, they are all connected via this really fast HDR, ADR fabric with that offers up to 400 gigabytes per second speed. So that's the level of connectivity we have for for each compute node stationed on the Holyoke data center. Whereas the other two data centers that manage our storage and login and stuff like that, they are all on conventional TCP/IP network. So that's kind of how the whole thing is set up. But the Canon, the compute cluster, which is in the Holyoke data center, it utilizes a really complex but very green liquid cooling system, which was developed by Lenovo some 3 years back, I want to say, along with Intel to efficiently cool each of our compute nodes. And that was the reason. So the technique, the reason why it is so special is because this technique actually allows for CPUs to run at higher clock speeds without adding additional air cooling. So, the CPUs are not really asking for a lot more,
Mm.
but they're running faster. So, and that was actually one of the reasons why our Canon cluster made it to the top 500 list. And it's been there since 2019. In that top 500 list that tracks the HPC clusters worldwide. So we
Wow.
are in the and in within US, we are in the top 10 academic institutions with this kind of a computing cluster.
Wow. Wow. Fantastic. I mean, it stands to reason that it would have to be a very substantial piece of kit to deal with that level of computation. But it's also, like I say, all the other factors around that when you're dealing with the considerations of that level of performance, like you say, around cooling and things like that, that it just you don't necessarily think about on an average day. But yeah, it's a mammoth undertaking, isn't it?
Yes, and that is something that I learned myself because so I had been a user of supercomputing facility pretty much, since my graduate years, but I actually never thought what all goes in the back end. So
Mm,
this is my opportunity to learn about the back end, and it's just simply amazing because I think, and I might be, I may not be wrong to say this, but really this high performance computing area or research computing area is probably the only domain that brings scientists, systems, storage, software, and network engineers all together in one place
mm,
just with the goal of facilitating research.
yeah.
I don't think I have seen it anywhere else but here. And that's the reason why it's the massive scale, and all the type of complex programs that need to be enabled to run on these resources.
Talk us through some of the other kind of key challenges, I guess, that you encounter when dealing with a distributed HPC cluster such as that. What other kind of issues and challenges do you encounter on a daily basis?
Yes, so I would say a major challenge or a few challenges that come to us on a daily basis is um, there is documentation, but somehow it doesn't make its way to the users. So a lot of times they're not aware on like how to even get started on the cluster,
Mm.
which is still a mystery how that can happen, but that is something that we are trying to solve. uh, and then the other challenge is users do not realize that when they put their workflow on a shared supercomputing cluster, the shared is the key word in this case. So everything that they do on their laptop doesn't necessarily translate exactly that way on a shared cluster. The permissions are different, the environment, the setup, all of that is very different compared to when you just want to open your laptop where you're by default an administrator and you do your installation. So a lot of times users need to be educated about that difference. And I think that is the challenge to kind of, when you're in an HPC research computing domain, the main challenge, at least in my opinion, is to educate a user about the constraints that come with the shared cluster.
Yes.
Because unless and until they're aware of those constraints, they will keep on complaining that why is this not working instead
Yeah.
of figuring out ways to make it work. So
Yes.
that's kind of One of the things I feel, could be training related, could be outreach related. So there are multiple reasons for why that is the case, but at least that's one of the challenge I
Mm.
have faced
Yeah.
so far.
I can imagine. I can imagine. And similarly, what's your view on how you address the issues around security? As I suppose, as data and AI based platforms become increasingly pervasive, what are some of the kind of key security considerations that you have to take into account as an academic institution, especially if you're leveraging certain NLP platforms and tools like Hugging Face, for example. Talk us through some of the considerations there.
Yeah, so I think for the most part, I mean, again, this is also very much an evolving area because a lot of US universities, including Harvard, are still kind of trying to figure out the guardrails, the policies that they should put around Gen AI use in your everyday life. I mean, it is happening. It's going to happen. You can't stop it, and I don't think by any means you should stop it. But what you should do is you need to um, educate the user. You need to reach out well ahead of time to tell them how to utilize it in an ethical way, in a safe way. And so there are two aspects to it, at least in my opinion. So there's the ethics part of it, and there's the safety part of it. The ethics is more around. I think a lot of it could be also common sense driven, that if you're asking someone to do some work for you, once the work is done, you should take steps to validate it, verify it, right? If you're not doing it, then you cannot blame the AI for it. You should just blame yourself for not verifying, because
Mm.
this is this is how any scientific method works, where you need to verify anything that you are trying to accomplish before publishing.
Yes.
That's so I think a lot of universities are making efforts where faculty is free to kind of have their own personal policies in the classroom, but there are general guidelines that yes, this is what all students should know about.
Mm.
And one of those being that be on the alert for verification, validation. You should not just, because you want to verify that any information being given to you is not a hallucination.
Yes.
So all those things are being already talked about. Harvard University already has had multiple workshops and seminars to discuss these issues and what can be done or what is currently being done. And then the next part of it is around safety, and that also is um is an evolving area, because you cannot put any kind of guardrails based on your previous knowledge, because the whole area is so much more evolving. So just to give you an example, if let's say someone is trying to download or install OpenAI software on the cluster, I mean, we cannot stop them from doing that. It's allowed. It's totally fine to go ahead do it. But now, if the user is not informed about the type of data they can use while using the OpenAI tool, that is a safety problem,
Yeah.
because they need to be made aware what level of security level that data has, and what has to be followed or honored when you're trying to process or use the data with the tool. So
Mm.
that's so and I feel the reason why I keep saying evolving is because don't have a standard process or policy around how to accomplish it. So everyone is figuring their own way out. So,
Mm.
for example, Harvard University has put some guidelines, and we are aware of it, but 100% of all the teams within Harvard University are aware of it. I don't know,
Mm.
but I cannot assume that. So, at least from my side, I'm trying to take an initiative where I'm trying to reach out to certain divisions, of users who already use our cluster, to kind of inform them that, hey, there is an agreement that Harvard University has with OpenAI. Um, let's know about it and make sure that all the users who belong to your division are aware of this agreement. So so the idea is you need to be always mindful of what type of data you're putting on the cluster and whether that level, the security level that data has, is allowed to be processed by a Gen AI tool or not.
Yeah, yeah.
So I think that mindfulness is the key here, and that is what we need to tap into.
Yeah, it's a really great point, isn't it? Because, like I say, so many of the people. I mean, Harvard University, obviously a leading academic institution, but so many people are in a very similar boat where, as I
Mhm,
said, there isn't a precedent for this, and everybody is sort of finding the guardrails. And because it is such a rapidly evolving field, it's for the first time in a long time, I guess, technology is advancing at a rate that a lot of processes and operational processes can't necessarily adjust to in the same time frame. And it's a really kind of interesting dynamic, I suppose, isn't it, as time goes on, and where we sort of go from here, with the rise of a lot of Gen AI based solutions, and how we sort of continue to police that from a safety, efficacy, and
mhm.
security point of view. But with your sort of future goggles on, looking into the future, how do you sort of see that whole landscape evolving around the evolution of AI, and in particular, sort of where it intersects with academia and research? Sort of whilst looking through that, how do we maintain security protocols moving forward? How do you see that whole thing panning out?
Yeah, I think, I mean, it is already happening. So students are using it for their research. They are using it in their classrooms for coursework. Um, I mean, staff is using it in their administrative work already. So
Yeah.
it's there, right? So it's being used in research, it's being used in administration, in teaching. Um, so I don't think that the comfort factor is going to be a problem because people are already pretty comfortable with it. But again, going back to security, what I also just thought of is that another issue that typically could happen is when you are fully invested in your work, you know, you may not actually even think what that that you have to be mindful of the data level security while you're thinking about your research project, and I mean, it does not come to you naturally. So I think that is, again, mindfulness is the key, like how to make this as a second habit for our researchers. I
Yeah.
think that is going to be the next challenge for research computing teams across the institutions that have these type of clusters, like how to bring that awareness to the users, so that if it's a second habit, they're not getting interrupted by it, but they're just making it part of their work. Because we don't want to disrupt users when they're thinking about their work, they're trying to do research. We totally understand that it should be uninterrupted,
Mm.
but how to have that awareness, kind of, um, how to make that awareness happen naturally, that is where the next challenge is. So another way to look at it is, and I often tell my teammates, if you're in a laboratory, you're you're doing your experiment, you will be very mindful of prepping the equipment, prepping your entire experiment before you start conducting it in a lab. But a high performance computing cluster is a lab, it's a numerical lab. So people, because they're not physically present here, they don't think about all these protocols that they would have otherwise when they're in a physical laboratory. And I think that is kind of research computing team's responsibility to make that happen, to kind of tell the user that when you come to a cluster to do your work, think of it as a numerical laboratory. You're responsible for prepping your data, executing your data, and then cleaning up after the work is done.
Mm.
So
Yeah.
so
Yeah.
it's good to have that parallel in mind and then kind of educate the users with that. So I think anything which is tangible is easier to maintain, is easier to be mindful of.
Yeah.
Anything like this, which is all virtual, be like, who cares?
Yeah.
Sometimes it doesn't come to them as second habit.
Absolutely. Yeah, it's a really great point, actually. I think anything in the kind of digital realm, it's a
It's
really fine line, isn't it? Very, very fine balancing act between fostering innovation but still operating in a effective way, and being aware of constraints. So yeah, very good point. Not never heard it put like that before, but I can take that
yes.
picture away, and I think it's a nice nice metaphor.
Mhm.
Perfect. Okay. Well, let's sort of close by talking a little bit about you, Manasvita, in terms of your leadership style. I suppose you're clearly a very inspirational figure, doing some really interesting work, and a lot of respect for the self-awareness of the areas you've had to develop on over the years to get to the place that you've got to now. But what do you feel are some of the traits, the traits of a great technology leader, great sort of data focused leader in your experience?
Sure, yeah. So I think I can maybe answer this by sort of putting it in two parts. So one is the technology and one is the leadership, right? So I think in the tech world, it is such a rapidly evolving world, no matter which domain you look at, that you need to have an open eye and ear for the latest technology, keeping yourself up to date. You should have the ability to gauge the importance and relevance of a technology and the implication of that technology in your domain, because otherwise, you may just lose out on not just the competition. It's not just about competition. You may just lose out on what the technology can add to your daily work if you're not cognizant of that.
Yeah.
And then, which also means that you should be willing to adopt that technology and adapt to it if needed. And then, from the leadership point of view, I feel that you should have the ability to teach people in your team, in your organization, the importance and relevance of this technology that, let's say, you have gauged to be important or assessed to be important. If it's, and then um, it's thinking that you should be able to do it all. I don't think that is the correct way to move forward. But creating a space to do that or facilitating the space for the organization to do it, to be able to so that your team members can go ahead and explore, evaluate technology on their own, and maybe even create a software or technology that can be used by others. I think as a leader, you should be in a position to enable all of that. So
Yeah.
that's kind of how I think about it. Um, and then setting the culture and tone of constantly learning and evolving and having that growth mindset is I think some of the qualities that I would want in if I'm being led by someone. According to me, a technology leader or a data leader should be someone who can be compassionate, is collaborative, goal oriented, is a mentor, but at the same time a learner because you need to constantly learn, and you are objective with a growth mindset, and a visionary because you want to set the path forward. So you need to have that vision.
Nice. Yes, it's a nice Venn diagram of those different areas and where they overlap. So yeah, can see that absolutely. So well, look, been really really fantastic speaking today, Manasvita. I really enjoyed the conversation, and yeah, genuinely riveting. Hearing some of the day-to-day challenges that you face in the work that you do. But I like to end every episode with asking the same question, if you'd be so kind to indulge me with your answer. And that is, throughout your career, it can be from a professional or academic context, what would you say is the one favorite piece of advice that you've received that you would care to pass on to your fellow human?
Yes, absolutely. And thank you for bringing up that question because so I know that's your favorite question, but um, so in my case, I would say that it's not one favorite piece of advice that I've received, but there are a few nuggets of wisdom that I have picked from here and there as
Okay.
I along the way. And again, these nuggets of wisdom, as I call them, are just something that I picked up from my interaction with my peers, my friends, my teachers, professors, parents, mentors, like the whole um, um, the entire consortium of people. So I think like to say some of those would be every minute counts or make every minute count.
Mm.
And then once you have a routine identified, stick to it, never shy away from hard work. So if I want to just summarize it, what it really means is stay focused, be consistent, and do hard work. So these, according to me, are the three pillars for a fulfilling career. But
Yeah.
at the same time, don't neglect your health and family so that you can have a fulfilling life.
Yes. Yeah. Fantastic. I think yeah, I really like the sort of bringing both of those elements into play there, because I would agree with you. I think consistency is such an underrated facet of success in, I'm sure, academic world, but professional world as well. But like you say, it's always with a view to what am I working hard for? And I guess that's thinking about your personal life and your family as well, and being present for them. So yeah, I like that a lot. Definitely happy with those nuggets as a way to finish. So yeah, I guess nothing else remains but to say thank you very much for coming on and chatting with us today. Really, really interesting stuff, and I'll look forward to yeah, keeping my eyes closely peeled for your future successes as a team. So
Yes, absolutely. Thank you so much. And all the best to you too.
thank you very much. I'll speak to you very soon.
Yeah.
Bye for now.
Bye.